Alrighty, I'm going to solve number 2 for the video solution. And the question asks to let W be the subspace of R3 with basis vectors W1 and W2, and to find the closest vector in W to V, this vector V here. And so because we can see, for sake of time, I'm not going to do it out, but if you do it out beforehand, you can see that W1 dotted with W2 is equal to 0. And so we know that W1, W2 is an orthogonal set. And then because neither W1 or W2 are 0, it means that the set W1, W2 are linearly independent. And therefore, W1, W2, that's an because of these two conditions, that makes it an orthogonal basis for W. And because we know it's an orthogonal basis, therefore, the answer is just equal to the projection of W onto V, where V is dotted with W1 over W1 dotted with W1. And this is a known equation. When these equations are satisfied, when you know you have an orthogonal basis with a subspace, you can just use this equation that is that's known to solve for the projection or the vector that's going to be closest to V in subspace W. And then that's plus V dotted with W2, W2 dotted with W2. Apologies for the messy handwriting. I'm trying to make this in time. And so we can see that V, and then so I'm going to just do out these dot products real quick. V dotted with W1 is going to equal 4/3 minus 1/3 minus 6/3. So that's going to equal -1. W1 dotted with W1 is going to equal 4/9 plus 1/9 plus another 4/9, which just gives us 1. And so we can see now that V dotted with W1 over W1 dotted with W1 is just going to be -1. And so we can then substitute that back up here in the original equation. I'm going to do these dot products real quick. And so V dotted with W2 is equal to 2 over root 2 plus 0 plus 3 over root 2. So that's just going to equal 5 divided by the square root of 2. And W2 dotted with W2 is equal to 1/2 plus 0 plus 1/2. And that's going to just give 1. So when we want to, and then we can say that V dotted with W2 over W2 dotted with W2 is just equal to 5 over root 2. And so plugging this back into the original equation, we can just say that the projection of W onto V, or the point in W that is closest to the vector V, is just equal to negative W1 plus 5 root 2 W2.